Chapter 8, Section 8.1 and 8.2. All the formula that we need for Section 8.1, 8.2, and even 8.3, they are dealing here. These are for calculation of the mean. So to calculate the mean, if a standard deviation of population is not given and function is normally distributed population is normally distributed, or a standard deviation of population not given by n greater than 30, then we are using T formula. In case we want to calculate mean and a standard deviation of population is given and normally distributed populations, or a standard deviation is known and n is greater than 30, then we are using the Z. So all the formula are the same. It just we have to either use T table or Z table. So first we want to discuss about the Z table. So here also we are talking about the claim. Let's say in a statistic, a hypothesis is the claim or a statement about the property of populations. Hypothesis test or test of significance is a procedure for testing a claim about a property or populations. Examples. We claim that mean body temperature of human is less than 98.6. So in this section, there are two types of hypothesis. One, they call it null hypothesis. And the other one is alternate, H1, alternate hypothesis. And let's say we claim there is a can of soda, and it said that it's 12 ounce. These are just the examples, okay? So manufacturer claim that there is a can of 12 ounce of soda. So in that case, HO is weight or mean is 12 ounce. What is opposite of that? Opposite that is not. So in this case, claim is HO or null hypothesis. Let's say another example. In one particular town, we claim that proportion of the males are greater than 40%. So original claim is this. Original claim is that in this particular city, proportion of the male or male students, for instance, are greater than 40%. So that is H1, and opposite of that is HO, which is P greater, that is less or equal to 40. So what it is, these two are always opposite of each other. So you claim that in this particular city, proportion of the males is greater than 40. If we prove that that's not true, if we prove that is equal or less, then we reject the claim. So it's either accept or reject the claim. And normally, for the opposite in this situation, we just put equal. We don't even have to put less, because if we prove that is equal, means it's not greater than 40. So these are the claims. So the claim can be about the mean, claim can be about the proportion or a standard deviation. Like here, population of college student has IQ score with a standard deviation equal to 15. See, this is a claim for standard deviations. Or proportion of consumers not comfortable with the drone deliveries is greater than 0.5. So that means this is a claim about the proportions. And then this is the top one is a claim about the mean. So claim can be about the mean, proportion, or a standard deviation. And for each of these, we have the formula. See, here is for proportions, for the mean, and a standard deviation. So HO, they call it null hypothesis. H1, they call it alternative hypothesis. HO always take equal sign. So in the problem, if you have less, greater, or not equal, that is H1. HO always take an equal sign. And this is a chart that when we identify the claim, we have to see whether it is less, greater, or equal, and then we go through this chart. And this table is important to understand that this is a confidence level for confidence interval. If significant level is any of this, for two-tailed test is this one, and one-tailed. We have some examples that we could use this, and we could show it to you later. Again, these are about null hypothesis, always take the equal sign, but H1 can be greater, can be less, can be not equal. Now, in these sections, our graph could be two tails or could be one tail. When it's one tail and tail is on this side, then we say less. They call it left tail. They call this right tail. Right tail is when H1 is greater. So H1 determine whether you have two tails or one tail. And if it's one tail, H1 determine whether it's a left tail or right tail. So when we are working on the problem, we got to pay attention to the symbol of H1, because that would determine which graph is the one we need for the problems. So it's a two-tail test, left tail, and right tail. All depend on symbol that we use for H1. Another formula is the p-value and alpha. When we go through the example, then you understand where we apply this. If p-value is less than equal to alpha, we always reject. If the p-value is greater than alpha, we accept. We fail to reject HO. There are two types of the error. We don't really have any examples on, the homework problems. But type of one error is when we reject null hypothesis or we reject HO by mistake when it's correct. Means HO was the correct, but by mistake we reject it. Type 2 error is we accept HO by mistake when HO is false. Again, section 8.2, we are using some formula which is on that page of the summary that I show you. I summarize all this formula. Now, examples. In chapter problems, 1,009 consumers were asked if they are comfortable with having their own delivery their purchases. So N is 1,009. 54% of them responded with no. So P hat means proportion of the sample. Proportion of the sample, we have this hat at the top. Capital P is proportion of population. So 54% respond with no, so that means P hat is 0.54. Test a claim that most consumers are uncomfortable with their own deliveries. So in these problems, P is given, Q is always 1 minus P. So when we give you the value of the P, all you need to do is subtract from 1 to find Q. Everything else is given. Formula for P hat is X over N, proportion of the sample. So in these problems, the claim is that most consumers are comfortable with some deliveries. Means most means more than half or greater than 50. See, we interpret most to mean more than half or greater than 50. So original claim is this, is more than 50%. What is opposite of that? Equal or less, HO. But we normally use equal because equal is opposite. We don't have to put less. So original claim is H1. Remember, H1 determine whether it's a right, left, or two-tailed test is greater than the symbol of H1 is greater, therefore is a right tail. First, we have to see the requirement. Requirement is n times p and n times q both must be 5. We have the value of n is 1009, p value is 0.50. So in either case, is a large number is greater than 5. So we meet the requirement. Formula for p hat, proportion of the sample, is x over n. X is given in the problem, n is given, so that would give us the value. We already have this value. We didn't really need to calculate, but you could also do it this way. Now, they call this z statistic, z of test statistic for z. This is a z formula when you want to do the hand calculation. P hat is given in the problems, 0.54. Capital P is 50%. And n is given. So that gives us the z of testing or statistic or z from the formula is 255. Now, we need to find the z value for this significant level. Significant level given the problem is 5%. So to find what z value we have for this 0.05, the best thing is to use the calculator. If area is 5%, what is the z value? Second verse, inverse norm, 0.95, that gives you 164. So 164 is the z value for 5%. Now, the rule is this. If z of a statistic, which is 255, fall into the critical area, then we reject HO. Means we reject HO and we accept H1. So that means we accept original claim. Okay, so if there are two calculations, one is for alpha that is given in the problem, for significant level that is given in the problem, you calculate the z for this one. And that, by doing that, then you understand that your critical zone starts from 1.64. Then you take this calculation z of a statistical z that you find through the calculation. If this z fall into the critical area, we always reject HO. If this does not fall, let's say this was like 1, it doesn't fall into critical, then we accept HO. And when we use the calculator also would do for p-value. If you find the p-value that we see on the next several examples, you could also compare p-value with alpha, and then that would tell you whether you should reject null hypothesis or not. In this problem, when we find a p-value from the calculator happen to be 0.005. So it's less than 5%. Therefore, we reject HO. Normally, they must match. Means when you prove that there is a rejection of HO here, you should also prove rejection of HO by using the p-value. On these problems, again, n is given, p hat is given. Test the claim that for adult population, proportions of those who sleepwalk is less than. This claim is for H1 is less than 0.3. So in these problems, H1 is proportion less than 0.30, and the other one, HO, is always opposite, which is the equal. So HO is always equal sign, which is opposite of this. Again, first we check the requirement, n times p, n times q, both are large number, obviously greater than 5, so that means it is okay for us to use the formula. Now, we don't need to use this formula, we don't have to have the x. We need the x later on for calculator. So p hat is given in the problems, is 0.92. Capital P is 0.3. We have all the numbers. That give you the z of the calculation. Now, Alpha is 5%. Significance level is 5%. We have to see what is the z-value for this 5%. Again, you go to second inverse norm, you put the area, the calculator would give you the z-value is minus 164. So when you find a border point in minus 164, then if this number, minus 2.41, fall into the critical zone, which that's the case here, then we reject HO. If this number fall into critical zone, then we reject HO. Now, we could also use the calculator to do all this. On the calculator, you go to stat test. For instance, on these problems, you go to stat, you go to test, then to go to number 5, one proportion ZT test. Now, the p-value is 0.3, x is 5588, n is 1936. And now, what symbol we have to use here? Use the one for H1 is less. And you could see it here, it's less. So we are using less, which is already there. And then all I need to do is go to the calculations. Let me use my other calculator. My calculator is not on the default, but anyway, when you do that, there is a p-value from the calculator, and that p-value from the calculator, if it's less than alpha, which is 5%, then we reject HO. So these two must match. I don't want to waste the time on this one. All right. The next problems. Again, on this one, always read the claim. Test the claim that more than 20%. So the claim is proportion is more than 20%. That's the original claim. What is the opposite? Equal. Very similar to the other problem. Requirements are met. Both are greater than 5. And based on 5%, you have the border 1.64. Why is the right tail? Because H1 is greater. That determines the right tail. And then if this number fall into the good area, doesn't fall into the critical zone, then we accept HO. We do not reject HO. Now we want to do the formula here. So in that case, we go to test number 5, one proportion ZT test. 0.2 is the capital P. X is 52, N is 227, and is the right tail is a greater. So symbol of H1 is greater. Z value is 1.095. That's the number that you have here. Now, p-value is 0.136 or 0.137. So that's the number that you find through the calculator. If that p-value, the number to the calculator, this number 0.1367, that number is a p-value. If that p-value is less than alpha, you reject. If that p-value is greater than alpha, which is the case here, then we accept HO, and that match here. You also see that your Z does not fall into the critical area. So based on comparing the Z, we know that we accept HO. Based on p-value, we also know that we should accept HO. So these two should match. So in both cases, we accept HO. That means we reject the claim. We reject the claim. You should remember, in case of two-tailed test, when you use the calculator, even for inverse T or inverse norm, calculator always use area of one tail, okay? So in that case, if you want to do the p-value that you find from the calculator, you have to multiply by that. You have to multiply that by 2. You have to multiply that by 2 in order to compare with the alpha. So just for two-tailed tests, when you find the p-value from the calculator, that p-value must be multiplied by 2 in order to check with alpha, because alpha is the area of two tails. But what the calculator give you, when you give you a p-value is for one tail only. But in case of two tails, you have to multiply that by 2. See, we apply that one in these problems. When we went to the calculator will give us the p-value of 0.50, but we multiply that by 2 and then compare to the alpha on this one. Now, homework section 10.1, the solution is here. Now, 1 and 2. Number 3, you could calculate the value through the table. I'll show you how to do it through the table. So in these problems, Z is 2.22. They want to know what area is for 2.22. For that, you could use the area for 2.22. You could find the area, 0.9868. And when you subtract from 1, that gives you the area of here, 0.0132. That's your p-value. And then you could compare that with alpha that's given in the problems. Or you could also, if you don't want to use your table, remember you could use the calculator. And calculator, if you say second verse normal CDF, and you put the lower one as 2.2, and see, if you have the Z value and you want to calculate the area, let's say you want to calculate this area. The lower number is 2.2. What's the highest numbers? You always pick a large number like 10. So you need to use second verse normal CDF for the lower 2.22, upper 10, and then that gives you the value of 0.013. That gives you this value that we had to do through the calculations. You could find it through the calculator. So we don't really need to use the table. Number 4, if you want to use the table, that's how to do it, to come with 0.9940. and p-value is 0.12, and then you compare p-value with alpha. These problems are all very similar. On this one, the second Var's inverse norm, is for 0.01. We find the z value. So this is a z based on this 0.01, and then compare that with z of a statistic. Z of a statistic is minus 1.69, which fall into the good area. It doesn't fall into the critical. Then we accept HO. So here is comparison of z of calculation with z through the calculator. Means significant level of alpha is 0.01. So for 0.01, we go to the calculator and find what z we have. So that tells us the border point. This z is minus 2.33, but then the other one fall in the good area. It doesn't fall into the critical. Therefore, we accept z of a statistic does not fall into the critical zone. We conclude to accept HO. When you accept HO, means you have to reject original claim. Now we go to homework section 8.2. These are all multiple choice. On the second page, I'll put the right answer for you. See, they all are using the same function on the calculator to find the p-value and make a comparison. These problems are all the same, very similar. All the same function of the calculator. PO is 0.20, is a capital P, X is given, N is given. This is the sign of H1, which is less. Calculator would give you the Z of calculations and also the p-value, which if this E means times 10 to the power of -4. So when you see E minus 4 on the calculator, E minus 4 means 10 to the power of -4. So that means it's a very, very small number, 0.001. See, for all these problems, if you go to this function of the calculator, you could find your Z and the p-value, which they're asking you here, and then do the comparison.